You know, your body is under constant attack, pretty much 24/7. So how does it fight back? Well, it doesn't just fight, it builds an entire army. And in this explainer, we're going to take a tour of how your immune system recruits, trains, and deploys this incredible, highly organized cellular fighting force. So really think about it. How does your body actually build a microscopic army that's powerful enough to protect you for your entire life? It's really a biological marvel. And the whole thing unfolds in three, you could say, distinct stages.
Yeah, it's a story of recruitment, of training, and then deployment. We're going to follow these little cellular soldiers all the way from their birthplace, see them go through boot camp, and then watch them head out onto the front lines of your body's defenses. It's going to be quite a ride.
Okay, so our story starts right at the very beginning. We're heading to the recruitment centers, the place where every single one of these defender cells is born. All right, the official name for this whole recruitment process is hematopoiesis. I know, it's a bit of a mouthful, right? But it's actually pretty simple. It just means the constant, lifelong production of all your blood cells. And here's the amazing part. Every single one of them, your entire immune army, originates from just one incredible type of master cell, the hematopoietic stem cell. Now, what's really interesting is that this production headquarters doesn't stay in one place. It actually moves around as we develop. So it starts out in the yolk sac when we're just an embryo. Then it shifts over to the liver and spleen as a fetus. And finally, from the day you're born and for the rest of your life, it settles into its permanent home, the bone marrow. Okay, so once a new recruit, a brand new stem cell is created, it gets to a point where it has to make a choice, a really big one. See, it can't just be a jack of all trades forever. It has to specialize.
And this is the first major fork in the road for that cell. It has to commit to one of two main paths. On one side, it can become a common lymphoid progenitor. Think of these as the parents of our specialized targeted assassins, like our B cells and T cells. Or it can go down the other path and become a common myeloid progenitor, which gives rise to the immune system's first responders and the all-important cleanup crews. But here's the thing. This decision isn't random at all. It's actually guided by the local environment. You can totally think of it like a drill sergeant shouting orders. The surrounding support cells, these chemical messengers we call cytokines, and even just direct physical contact. All of these things are telling that new cell exactly which specialty it needs to choose.
So, our new recruits have their initial assignments. They know what they're going to be. Now, it's time for boot camp. They need to mature, they need to learn how to fight, and all of that happens in what we call the primary lymphoid organs.
The whole system is really nicely organized into two main types of organs. You've got the primary organs, those are the training academies. That's where our lymphocytes are generated and mature. And then you have the secondary organs. Those are like the forward bases. That's where these fully trained soldiers are stationed, ready to kick off an immune response. Now, for one group of these cadets, the B lymphocytes, their training happens right at home. They actually mature in the bone marrow, the exact same place they were born. So it's like the central headquarters for both recruitment and training. Super efficient. But the other group, the T lymphocytes, well, they have to pack their bags and travel. These T cadets migrate away from the bone marrow and head to a really specialized academy called the thymus. And it's here that they go through this super rigorous training to become highly effective, specialized operatives.
And hey, speaking of B cells, here's a fun little factoid for you. Why do you think they're called B cells? What does that B stand for?
Now, you might be thinking it stands for bone marrow, right? I mean, that makes perfect sense since that's where they mature in us humans. And you know what? That is a fantastic way to remember it. But it's actually just a lucky coincidence. The real reason is, well, a little more feathery. The B actually comes from the bursa of Fabricius, which is an organ where B cells were first discovered, in birds. Yep, so we have chickens to thank for the name. How about that?
All right, our B cells and our T cells are trained up and they are ready for action. So now they get deployed to the front lines. And those front lines are the secondary lymphoid organs. This is where they're finally going to encounter the enemy. So think of these secondary organs as our strategic outposts and watchtowers. You've got the spleen, which is the main surveillance hub for your blood. Then there are the lymph nodes. They're the checkpoints for the entire lymphatic system. And finally, you have this massive network called MALT, and it basically stands guard at all the mucosal borders. Let's talk about the spleen for a second, because it's an absolutely incredible organ. It's basically a giant filter for your blood. Any microbes that happen to be floating around in your bloodstream, they get trapped here, where your immune cells are just waiting to destroy them. And as a bonus, it also cleans up old, worn-out red blood cells. Your lymph nodes, they work in a pretty similar way, but they're focused on the lymphatic system. See, as this fluid from your tissues, we call it lymph, circulates back towards your blood, it has to pass through these little nodes. And they act just like security checkpoints, trapping any signs of an intruder so an immune response can be launched right then and there.
But of course, not all threats are already inside. Most invaders are trying to break in from the outside, right? And that is exactly why our body has a massive, dedicated border patrol force.
And I really want to stress, this is not a static defense. These guys aren't just sitting around waiting. Your mature lymphocytes are always on the move. They are constantly circulating between your tissues, your blood, and your lymph, actively patrolling every single corner of your body, looking for any sign of trouble.
Which brings us to MALT, that's mucosa-associated lymphoid tissue. And the sheer scale of this system is just staggering. Get this, over 50% of your body's total lymphoid tissue is part of the MALT system. That's a massive, massive frontline defense network.
And when you think about it, this makes perfect sense, right? MALT is there to guard all the places where the outside world meets your inside world. So you've got NALT and BALT in your airway, protecting your nose and lungs from anything you breathe in. And then you've got GALT in your gut, which has this incredibly complex job of figuring out what's harmless food versus what's a harmful microbe.
So this entire system, from the moment a cell is recruited to the second it's deployed, it's just a masterpiece of defensive engineering. And it's all built on one absolutely critical principle: recognize and destroy anything that is not self. But that raises a final and pretty crucial question, doesn't it? What happens when this incredibly powerful army makes a mistake and turns on self?